Hi there. Here's a video to illustrate the difference between speed time graph and velocity time graph, and I hope it's useful for you. So just by using, I'm going to use this simple example of how a ball is rolling from a horizontal surface up a slope, and it comes back down. So there are three key positions that we'll look at. So when you're analyzing the motion of something, it'll be useful to look at some key positions. So for example, I will be looking at the position from 1 to 2, so 2 will be the beginning of the slope, and from 2 to 3, and back from 3 to 2. So this is going to, so first we must understand the motion. Now, we're analyzing from position 1 onwards. So at first, from position 1 to 2, it travels at steady speed, which means at constant speed. Okay, and when it approaches position 2, as it's going up the slope, it will start to slow down because it is opposing gravity. So because when it's opposing gravity, then it would slow down. And because it's opposing the same amount of gravity, it would slow down at a constant rate. So over here, we're assuming that the effects of air resistance will be negligible. And when it approaches to the highest height, which is 3, so it definitely it will reach a maximum height and it has to roll back down. So at 3, it will be momentarily stopping. So I wouldn't say that it stops there and not move, but it would just stop for like a split second. So it would momentarily stop before it changes direction. So from position 3 to 2, it will be coming down because it's being pulled by gravity. So it will then speed up. So when it speeds up, that means it will accelerate because it's being pulled by the same amount of gravity coming down and the slope doesn't change. So it will be constant acceleration from position 3 to 2. Okay, so there'll be another video that actually looks at the forces acting on the ball and how it affects the motion. That we'll do it separately. So today we'll focus on how do we sketch a speed time graph and a velocity time graph for this particular motion. Now maybe you want to try sketching it first and pause the video and just try it. So I assume you have tried your version of speed time graph and velocity time graph. So let's try doing it together. Now, when we are planning to have a velocity time graph, we have to define the motion. So basically, the ball goes in one direction and it's going to reverse. So the initial direction, I'm going to label it as the positive direction. And in the reverse direction, we call it negative direction. All right. So let's look at a speed time graph first. So from position 1 to 2, it is moving at a steady speed, so which means constant speed. So it will be a horizontal straight line. So that will be your position 1 to 2. And as it rolls up the slope from position 2 to 3, it will be slowing down at a constant rate. So because the same amount of gravity is pulling on it, so it will be slowing down because it's opposing gravity until it reaches the maximum height at position 3. And at position 3, it will be momentarily at a stop, just stop for a while before it changes direction. And after that, when it's rolling down, it's being pulled by gravity. So it rolls back down to position 2. Okay, we're going to stop right here. But after position 2, because it's no longer on a slope, so therefore, it will continue at a constant speed. Whatever speed it was at, and now it will continue at a constant speed back to position 1. All right. Now, how would the velocity graph look like? So let's look at it here. Now, the velocity time graph, the velocity for position 1 to 2 would also be a constant velocity because the ball is moving at constant speed, so it will be at constant velocity. So this is for position 1 to 2. And when it approaches the slope and is going up the slope, it will also be decreasing velocity because it's slowing down because of the fact that it opposes gravity. And when it reaches position 3, it will be momentarily at a stop, just before it changes direction. Now this is now going to be where the difference lies between velocity and speed time graph. All right. So because the ball has changed direction, it's going into the negative direction as we have specified here. Now, assuming, we'll just put in some numbers because this is a arbitrary number. So we'll just put in some numbers. For example, you have -1, -2, -3 in the negative portion, for example. So when it goes, so after position 3, the ball is going to change direction. So the velocity, although it is accelerating, but it goes into the negative direction. So therefore, the graph would be negative, which tells you that the ball has already reversed its direction. And now you must be saying, but well, it's accelerating. Yes. So as you can see, the velocity is going from like increasing speed, but the negative sign tells you that it has reversed direction. So the negative sign doesn't mean that it's getting a smaller number, but instead it just gives you an idea that the ball has reversed its direction, but the speed is actually increasing in the negative direction. And after that, because it reaches position 2, and after subsequently it goes into the horizontal surface again, goes onto the horizontal surface, so it would then it will go at a constant velocity. So in this case, you can see that for the speed time graph, it simply gives you the value of the speed. Constant, decrease, increase, constant again. So it doesn't tell you if the ball has changed direction or not. So we wouldn't actually know if you are only provided with a speed time graph. However, when you're being provided by the velocity time graph, it gives you a little bit more information in terms of the direction. So you can tell that from position 1, 2, and 3, it is in the same direction, and subsequently when the graph shows a negative portion, the velocity time graph is showing that the ball has reversed its direction. So I hope this is useful for you to tell the difference between using a velocity time graph and a speed time graph. Thank you.